Alright, this first page for 5.5 hyperbolas is just information about what a hyperbola is, especially as it compares to the other conic sections we've learned about. So the definition here is a hyperbola is the set of all points in the plane such that the absolute value of the difference of the distance from two fixed points to a point on the hyperbola is a constant. The fixed points are called foci of the hyperbola. So this picture over here illustrates that definition. We've got a fixed point on the hyperbola, well, a point on the hyperbola, and the distance shown to one of the focuses, and then to one of the foci, and then the distance to the other foci. So then, gosh, I'm really bad at figuring out when to use plural and not. So the distance to one of the foci here and the other focus there, right? So if we take this distance and subtract them, that will be a constant value. And the reason it says absolute value is it doesn't matter what order we subtract them in, like smaller minus bigger or bigger minus smaller. The absolute value just gives us that positive distance. So here's another point. There's this distance and this distance. If we subtract them, we would get that same constant value. Again, understanding the definition entirely isn't something you really need to worry about at this point. So more importantly is understanding the details of the hyperbola. So we've got what we call the transverse axis, and the foci and the vertices in the center all lie on the transverse axis. What we learned previously in the last section was if this was a sum instead of a difference, then this would be an ellipse, and the ellipse would be in here, and the foci would be inside of it, right? But since this is a hyperbola, it's a difference of the distances, and the arcing is the other direction with the foci inside of that arc. So it's kind of like having two parabolas back to back. We also have asymptotes here that guide the direction of these branches of our hyperbola. Alright, so here's some of these vocabulary words I was just barely throwing out. We have our branches of our hyperbola, we have the center, we have the transverse axis, we have the vertices, where the hyperbola changes direction, just like parabolas. We have our asymptotes. We have our conjugate axis that's perpendicular to our transverse axis. And then we can create a guide rectangle using A horizontally, A, so like here and here, and B vertically here and here, to create this rectangle instead of where there would have been an ellipse, right? So last section we would have created an ellipse in here, and instead we've created this rectangle, and then through the corners of the rectangle we get our asymptotes that guide our graph. Alright, you can see here that the asymptotes, the slope of the asymptotes is going to be plus or minus b over a, because we've got rise b over run a in that rectangle when we put in those asymptotes. Alright, next. So hyperbolas can go this direction or this direction. So this is opening left and right, this is opening up and down. Both of these examples have a center at 0, 0, which of course our center can be elsewhere, but we'll get to that in a minute. So if it's horizontal with the branches to the left and to the right, then x squared will come first in our equation, just like we're used to, over a squared, but then instead of a plus in here like we had with the ellipses, we have a minus. And then y squared over b squared equals 1. So hopefully you see the similarity between ellipses and hyperbolas, and the main difference here is that negative. So then, that's if it's left or right. How do we change that so it's up or down? Well, that would be this formula. Notice all that's changed is that our y squared over b squared has swapped with our x squared over a squared. B is always with y, a is always with x. There's subtraction here. So this part is positive and this part is negative, and that is what causes our hyperbola to go the other direction. So the transverse axis on this one, when x is squared positive, goes first, is horizontal with the conjugate axis vertical. But when we put the y squared first minus the x squared, then our transverse axis becomes vertical, and our conjugate axis is horizontal. Okay, the last thing we need to talk about is how to find the distance to the foci C. Now, coincidentally, and actually it's not coincidentally because you can study it closer with the definition and understand all the math and geometry behind it, this is Pythagorean theorem. So here's another thing you've got to remember is with hyperbolas, we've got a minus here, but a plus here. With the ellipses, we have a plus here, but a minus here. Those two signs just switch. So fortunately, you're going to have that formula sheet to refer to remember. So just remember that finding C is always going to be the opposite of the sign in the equation itself. Again, we have our slopes for our asymptotes as plus or minus b over a. Okay, let's go ahead and do an example. All right, identify the vertices and the foci of the hyperbola given by the following equation. Graph the hyperbola. So let's go ahead and find a and b. I'm used to finding a first and then b, but look, y is first and then x. So this is going to be b, so b is 7, and that's our vertical distance. There's no h or k in here, which we haven't even really talked about yet, but we know enough to know that it can be there. So nothing there means center at 0, 0. It doesn't actually say find the center, but I'm going to write it down just because that's something you will need to be in the habit of doing. Okay, so b is 7, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now we're still going to need room for our foci, which means I probably should have chosen bigger graph paper for this example, or you could count by 2, so each square on your graph is 2 instead of 1, and then it might fit better. Up to you if you want to do something like that. Okay, so these are these our vertices? Ah, yes, because y is squared, and so this is going to open upward and downward as opposed to left and right. I just started saying left and writing left when I meant to write down. Boop. Okay, so that's because the y is positive and the x is negative, so that's how we tell. You could get into more detail with these and actually plug in points to see that that's really going to happen. But for now, I'm just going to let you trust me, if you don't mind. Okay, and so then a can be found by doing the square root of 32. And 32 is 16 times 2. So that would be 4 square root 2. And for graphing purposes, we really just want to know approximately the square root of 32. So that's between 25 and 36, which means it's between 5 and 6. We're going to do approximately 5.5. I don't know if that's correct, but that's good enough for our graph. So 1, 2, 3, 4, 5.5. 1, 2, 3, 4, 5.5-ish, right? Okay, so I didn't write down my vertices yet. Let's write those down. So our vertices are 0, 7, 0, negative 7. Now we need to find our foci, so let's do that by using our formula. C equals 49 plus 32. So we're just taking b squared and a squared. I know the formula I gave you was a squared plus b squared, but when you're adding, the order doesn't matter. So yeah, 32 plus 49 if you prefer. Those add up to 2 plus 9 is 11, carry the 1, 4 plus 3 is 7, with the 1 that's carried is 81. So square root of 81, which is a beautiful 9. So our C value is going to be up here, 2 away from our vertices. So that would be foci located at 0, 9, and 0, negative 9. So the last part we didn't do yet is to create the box. So instead of like rounding it out as an ellipse like we were doing last time, I'm squaring off those dimensions. Oops, this one's a little crooked. Oops, not trying to move it. I'm having issues. What else is new? Okay. Draw upward, that's better. Why does it always tilt at the last minute? Boop. Okay. And there we go. Perfect. So So now the asymptotes go through the corners of that box. So our box is 2A this direction, so A was 7, so it's 14 this way. Sorry, I was pointing the wrong way, because that's under Y, so that's the Y direction. So 2B that way, and then 2A this way, so about 11-ish this direction. And we make our box, and we have our asymptotes. And now we have everything we need to sketch in our graph following our asymptotes. I put that the wrong place because I was going through the focus instead of through the vertex. So something like that and like this. We've graphed it, we've found the vertices, we found the foci. I think we're done with that